I'm Mark Sponsler, and welcome to the Storm Surf Video Surf Forecast for the week starting Sunday, September 27th. Storm surf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see a gale producing 38-foot, 39-foot seas in the northeastern Gulf of Alaska, producing swell radiating towards the U.S. West Coast. Another step in the right direction. Then a little semi-tropical system of some kind in the far West Pacific, producing 21-foot seas, but not aimed anywhere near us. We have turned the corner, and fall is starting to develop. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help direct their track. We're in the northern hemisphere, finally, and believe it or not, we have a consolidated jet with winds pushing to 190 knots, falling south over the dateline, starting to carve out a trough, and that's what we're looking for. A trough helps create a counterclockwise flow aloft and down at the surface. That's the hallmark of low pressure, and if the winds that it generates are strong enough, that helps create seas. Seas, if they're high enough, eventually turn into swell, and swell, when it hits your beach, turns into surf. So we actually have a consolidated jet stream flow forming a trough in a good position in the North Pacific Ocean, supportive of gale development, and reasonably early, being it's September, in the northern hemisphere. All is good. All right, moving forward. As we get into Sunday night and Monday, that trough continues to deepen, almost starting to get a little bit pinched off, but still supporting gale development pretty strong as we get into Monday evening, and then pretty much pinching off, but not gone. You notice it kind of disappears, but then tries to re-energize again as we get into Wednesday, being fed by 150 knot winds, again offering support for gale development north of Hawaii or so, and pushing east, then starting to weaken, but still present as we get into Friday. I mean, the whole week looking pretty good, and then even as we get into Saturday, still consolidated jet stream flow, 130, 45 knot winds, something like that, continuing over the dateline into the Gulf of Alaska as we get into Sunday, a week out. Then we'll just go right on out to a week out from now, and it almost looks like another batch of wind energy is supposed to start developing over Japan or so, pushing out into the Gulf, out into the North Pacific. So all in all, given the La Nina pattern, given everything that's going on, this is actually a pretty good pattern and a good start to the fall season. Next up, we take a look at surface level pressure, surface level winds, and as expected, there is a gale. It's at about a 968 millibar gale in the northern Gulf of Alaska, producing a small area of 45 knot winds. And for the most part, this looks like it's starting to move out of the Northern California swell window. Still good, though, for Pacific Northwest up into British Columbia. And as expected, as we get into Monday, that fades, but we know there's another trough forecast to build here. And sure enough, look at that. A gale fires up about midday Monday, 45, almost 50 knot winds aimed almost due south right at Hawaii, and continuing into Tuesday morning, but then starting to lift off to the northeast, while another gale builds even behind that. And the two start to get in circulation with each other. The main one fades, secondary builds with 30 to 35 knot winds, again aimed south at Hawaii initially, and then sort of sweeping more off to the east, lifting northeast, and again providing decent support for gale development. Theoretically, some sort of a tropical system. We're going to discount that, seeing how it's 5 days or more out. Then things kind of back off a little bit. I mean, you do see a gale here, but all the wind, this is into Saturday night, almost a week from now, aimed north at Alaska. No support there. We're going to start looking back in that direction. Probably not this run of the model, but, a couple days from now, see if something more pops up out this way. So, all in all, looking pretty optimistic. Let's go take a look at the effect of those winds on the ocean surface. Here we are, significant wave heights. Now we're going back to Saturday because the gale that's currently up here started in the northwestern Gulf But 18Z Saturday was at about 11 a.m. Saturday, Northern California time, Started building instantly 30-foot seas to 37. This is the max seas over the entire domain, 37-foot seas. That was even before sunrise on Sunday, up to 41-foot seas. And then pushing, that was about it. At one point, the models had set up to 43-foot seas, but looks like about 41 was the most that it could do. Now let's go take a look at the forecast. Here we go. That gale pushes off up into Alaska, northern Canada. No longer of interest, but we know there's another gale right behind it. And sure enough, about midday Monday, 22-foot seas, building to 20, I think that's about 8-foot to 30-foot seas. Now, they're saying 36-foot seas. I don't know where that is. Let's see, 34, 154. Yeah, so that's up in here somewhere. Kind of doubt that, really. It seems highly optimistic. And either way, it doesn't look like it's aimed really at us. So this is the main focus, 28-foot seas, building to 32-foot seas over a tiny area on Tuesday, pushing not only swell towards Hawaii, but the U.S. West Coast. It fades out. Another one right behind it as we get into Wednesday night. Now this one not as good, maybe 23-foot seas, initially aimed at Hawaii, but it lifts north really fast. Its fetch doesn't get good traction on the ocean surface, but still 22-foot seas. That's good for like 13-second period swell. So one swell in the water, another one possible, another one behind that. None of them huge, but certainly rideable surf. That, and then the tropical system, if and when it materializes, has potential as well. Then here we get another system theoretically on Sunday. Most energy, again, aimed up at Alaska, but we'll see. Maybe things can change. We'll be glass half full kind of guy for a moment, but for right now, it looks like a pretty good run of surf is forecast. And that's just from the northern hemisphere. In the southern hemisphere, a week ago, a gale developed under New Zealand right there. 38-foot seas, nearly 40-foot seas. Last Sunday, there's solid 40 to 41-foot seas traversing the entire South Pacific Ocean through like nearly Wednesday. Swell is in the water, expected to arrive in California starting tomorrow, Monday. Like 21-second period, tiny, but building through the week. So not only is there going to be northern hemi swell, there's going to be southern hemi swell. Likely the southern hemi swell will be washed out and buried under northern hemi swell north of Point Conception. But down in Southern California, things, good, fun-sized southern hemi swell. Could be fun. Moving out, we're into now, but then there was nothing after that. We're looking, this is today, a tiny gale started building under New Zealand. You see it right there, a tiny area of, 38-foot seas lifting due north. And then building a little bit while pushing north, but really limited to just under New Zealand and fading out by Monday. So what was that, 36, 37-foot seas, aimed mainly, we'll say New Zealand, Hawaii, Tahiti. Yes, North and Southern California will see some energy from it, but let's see, it'll be a 9-day arrival time, so we'll see. If there's no northern hemi swell in the water at that point in time, yes, it'll be noticeable, especially down in Southern California at the top south-facing breaks. Northern California, probably not so much. So we're rolling out. We're 3 days out. We're into Wednesday, Thursday of this coming week. Friday, there was some indications of something. So actually, here's 28-foot seas traversing, pretty much going due east. Probably not much going to see, if anything, if that thing even forms. And then there was some hint of activity under New Zealand, but latest runs of the model, not quite so favorable. 28-foot seas, that's good for Hawaii, Tahiti, if it materializes, but that's a week out, so we'll keep our eyes on that. This time of year, typically the southern hemisphere, it's still productive, but it starts fading. The focus becomes the northern hemi, and certainly the number of waves per set, the frequency of sets far exceeds anything that ever comes out of the southern hemi. So the focus then turns, of course, to the northern hemisphere. So this is the point where we normally go looking for wind swell, given the time of year, given the northern hemisphere situation. We really don't want to see wind swell, but here we are Sunday, fetch of 30-knot winds off of Cape Mendocino, generating wind swell. radiating down into North and Central California. A little bit of like semi-tropical fetch producing 20-knot easterly winds pointed at the Hawaiian Islands. Maybe that'll generate some wind swell as well. Get into Monday. Oh, did you see that? Sunday night fetch pretty solid here. But as we get into Monday, the local fetch starts fading out relative to California. Big low pressure. You watch it here sort of taking over the picture. That becomes the focus. All winds die relative, trades relative to Hawaii, and trades, which would be north winds relative to California, just dissipate. And it's a light wind regime for the most part. We're sort of watching, there we go, 15-knot winds on Thursday night, a little bit into Friday. So Friday's probably a pretty blown out mess for California. And continuing into Saturday. And then Sunday, it looks like things die out. The tropical system, big unknown if it even materializes. We'll keep our eyes on it. A week from now, we'll know a lot more. And then trades a week from now start building relative to Hawaii. So maybe some wind swell along east-facing shores. Looking at precipitation, the obvious thing here, massive high pressure taking over the Great Basin, which really affects all of California, all the southwest U.S. in control. Brick wall, no precip probably going to make it down into even Washington. You see it's all, the line right now is aligned northern British Columbia and even drifting north of that. So, and the suspicion is that's the name of the game. I mean, look, you can see massive blocking high pressure here. That is not unexpected for the time of year, and certainly not unexpected during a La Nina year. Here we go into, we're a week out. Nary a hint of precipitation. Not good for fire danger, certainly. All right, let's move on. Let's look long-term, like medium long-term, and then long-term. The Madden-Julian oscillation for the medium term. El Nino, La Nina, the El Nino Southern Oscillation. That's our long-term indicator. So first up, the MJO analysis. We're looking for signs of the active phase of the MJO. And as we all know, there's two phases, the active and the inactive phase. The MJO travels from west to east, from the West Pacific on the equator to the East Pacific, and actually the whole way around the planet. Takes about 30 to 50 days to make the traverse across the Pacific on the equator, either the active or the inactive phase. The active phase helps feed energy into the jet stream, can help to kick off El Nino, and certainly helps support storm formation, especially when it's in the West Pacific in what we call the Kelvin wave generation area, that area just east of the dateline, 170 west to the far East Pacific, 135 east, 5 degrees north and south of the equator. When the active phase is in this area, it acts like low pressure. It can reverse trades. It can create what's known as a westerly wind burst, which can create a Kelvin wave that pushes warm water that's in this area, pushes it east under the equator. Eventually, 3 months later, it erupts off of Ecuador. If you get successive Kelvin waves driven by successive active phases of the MJO, that can kick off El Nino. Right now, that is not the case, though. So anyway, what we're looking at here, the arrows. Wind direction, wind speed from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here, West Pacific here. Here's the equator. The dateline, 180 degrees, right there. All right, in the East Pacific, strong easterly winds, trades, pretty much stronger than normal. Continuing over the Central Pacific, continuing into the Kelvin wave generation area. But it's not the actual wind speeds, it's because winds vary from time of year, so it's the anomalies, differences from normal for this time of year. And we see in the far East Pacific, the arrows are pretty much neutral, so these strong easterly winds are about typical for the same time of year. Same in the Central Pacific, but in the Kelvin wave generation area, they're stronger than normal out of the east. Stronger than normal trades. That is typically a sign of the inactive phase of the MJO. It does not support storm development, does not feed energy into the jet stream. That said, we've looked at the models. We see what's going on. So clearly, it is not a 100% guaranteed that the inactive phase shuts things down. Conversely, it's not 100% guaranteed that the active phase just starts the storm machine. But typically, over the long haul, that's kind of the way things work. All right, what's the forecast? So this is the whole planet on one chart. The blues and purples are easterly anomalies. Think inactive phase of the MJO. The yellows and reds, westerly anomalies. Where's the Kelvin wave generation area? The West Pacific. It starts right here and goes the whole way up the chart, right on that line, to about right there, 170 west. So you can look here from August 28th, you see nothing but easterly anomalies. It looks like the inactive phase of the MJO, but it's gone the whole month of August and supposed to continue well into October. That is probably more than the inactive phase of the MJO. A prolonged and non-stop inactive phase of the MJO is really La Nina. Likewise, El Nino is the exact opposite. Westerly anomalies, even not in the presence of the active phase of the MJO, sure sign of El Nino. Clearly, it looks like we're in La Nina. Strong east anomalies forecast in the Kelvin wave generation area, almost to a point south of California, for that matter, almost filling the complete Pacific Ocean for the next week. Going out 2 weeks, we look at outgoing long-wave radiation. Fancy words for cloud cover. If you have more clouds, that's the active phase of the MJO, because the active phase is like low pressure. So where are we? There's South America, Central America, Mexico. Dateline is, the equator is EQ right there. Dateline, 180 west, going right up there. So the Kelvin wave generation area is right there. The blues, negative anomalies, meaning more clouds than normal, meaning the active phase of the MJO. Now, wait a minute. We just saw a chart that showed nothing but easterly anomalies, which are typical of the inactive phase of the MJO. But here we go. Supposedly, the active phase of the MJO is over the Kelvin wave generation area, and all we're getting is easterly anomalies. That doesn't make any sense. And we can, more of the same is forecast 5 days from now. 10 days from now, the active phase weakening, almost gone, and all but gone 15 days from now. That per the statistic model. The dynamic model saying exactly the same thing. So, if you understand, though, that during La Nina, you still have active phases of the MJO, but they are basically muted. They don't do what they're supposed to. Normally they'd create westerly anomalies, and we'd see that on the previous chart. Instead, they're here. The active phase is trying to do its thing, but it can't even produce any westerly anomalies. At least that's what it looks like right now. Let's dig a little deeper. Phase diagram charts, another way of looking at the MJO, specifically at the active phase's exact position and exact strength. This circle here, assume you're looking down on the North Pole, and the MJO works its way around the planet on the equator. Okay, and the equator is out here, Indian Ocean, maritime continent, over the West Pacific, over the East Pacific, under the United States, Gulf of Mexico, across the Atlantic back to the Indian Ocean. Where the heavy dot is, right there, is where the active phase is. So almost to the West Pacific, and the further away from this circle it is, the stronger it is. So it's out here, it's very strong. Say that's pretty weak, a very weak active phase, and here's the forecast, and it's supposed to just get weaker as it moves into the West Pacific over the next 2 weeks. That per the statistic model, the CA model. The GEFS ensemble model, pretty much saying the same thing. Active phase in the very far West Pacific maritime continent, and just sitting there for the next week, going nowhere, meandering. Then the upper level model. Areas of green are areas favorable for precipitation. One can interpret that loosely to be the active phase of the MJO. Yellows and oranges, inactive phase. So, right, there's south. So this is a 40-day model. What is there? 8 or 10 panels there. I think they're 5 days each. All right, so South America, Central America, there's the equator, 0 degrees. Dateline roughly about there. New Guinea, Philippines, you get it. Kelvin wave generation area right there. The greens are, there's a couple little, not much, very weak active phase for the next fading, almost non-existent, and out of the Pacific on October 17th. Then the inactive phase of the MJO shows up, much stronger signature, and it does its trek across the Pacific starting mid-October into early November. So it looks like right now, whatever there is the sweet spot. Okay, so we're in we have easterly anomalies in the Kelvin wave generation area, but we're in the active phase of the MJO, and that's probably what's feeding the storm cycle, at least for the next couple of days, right? And that's supposed to continue in some fashion, we'll say, for about the next 2 weeks, and then it all falls apart. And then the inactive phase is going to come in and really stomp on things. So what's the point here? If there's waves, go get them now, because this is when you get two of these phases, that is the La Nina phase, a dry phase, and the inactive phase of the MJO aligned. They're both in phase. It sort of amplifies the inactive phase and really stomps on things. Now we got La Nina and the active phase. That's the equivalent of like cutting half the strength of the active phase out, if not more. But at least this is your sweet spot right here, the next, we'll say 2 weeks or so for storm and surf. Go get it now. And then it'll probably be a bit of a break as we get into the latter half of October and early November. All right, the CFS model. This goes out a month, right? Same deal. Whole planet on one chart. Kelvin wave generation area starts right about there, 135 east to 170 west, right there. Okay, and the blues are easterly anomalies, and you can see all pretty much. Here was our last active phase of the MJO in August, like a coherent with active phase with 2 solid contour lines. And then since then, we've had no real MJO signal, but persistent easterly anomalies. The forecast going for the next month, nothing but easterly anomalies. Whatever weakness there is in the easterly anomalies right now, it's only going to get worse as we get to about October 10th and beyond. And then certainly the inactive phase lines up with La Nina. They get in phase and they amplify each other, and then you get a strong easterly signal that will certainly not impart energy to the jet stream and certainly not help the storm track. That doesn't mean there won't be waves, but my guess is it'd be more high pressure driven wind swell than actual long period ground swell. And then finally, the 3-month CFS model. The forecast goes to the top. Past performance is down here. Just eyeballing it. Kelvin wave generation area starts right there, going right up through to about right there. Just going right up in here and looking in this area. Where are our westerly anomalies? We want to see yellows. We see a little hint of it somewhere in late October. Maybe a stronger hint as we get into December. But I see nothing but solid easterly anomalies. Maybe not filling the Kelvin wave generation area, but certainly California's like 120. So pretty much filling the entire equatorial Pacific from California the whole way across to the dateline and beyond. Let's overlay the MJO thing. Here we go. All right. This is the active phase, the solid contour active phase of the MJO. Very weak in the Kelvin wave generation area today. Supposed to fade out, and we'll give it 3 or 4 days. Okay. Equally weak inactive phase in early October. Now, according to this model, the active phase, this is very weak. It was showing stronger, considerably stronger a week or two ago. A anemic active phase supposed to set up mid-October, continue into mid-November. I think that's a little bit different than what some of the other models are saying. And then on top of that, massive easterly anomalies in control of the dateline in the East Pacific. Probably not good support, just weak westerly anomalies, not even hardly in the Kelvin wave generation area. Then another, I'll say, non-event inactive MJO, followed by another non-event active MJO. We were looking at this yesterday. Both these were a lot stronger. So this model really is jumping around, having a hard time figuring out what's going on. And then as we get into the December timeframe, inactive phase of the MJO sets up. Westerly anomalies in control, at least for a little bit, until you get to about Christmas. Then I suspect things are going to fall apart if this model is even accurate. Oh, low-pass filter. We want to look at that. All right, so this is what are we looking at here? The dotted contour. Where there's the dateline right there, building. It's been building steadily. 2 contour lines in control and covering a larger area as we get into December. This is a high pressure bias. This is the net effect of La Nina, high pressure taking over the Pacific. Low pressure here, single contour bias, low pressure bias in the Indian Ocean. We've been saying this before during La Nina. The low pressure bias moves to the Indian Ocean, if not the South Atlantic. That's where all the storm activity is. And high pressure takes over the Pacific and the storm machine shuts down. Now, these are just tendencies. I mean, it's not like lock solid high pressure, but by and large, the balance moves towards high pressure in the Pacific, and during El Nino, the balance moves towards low pressure in the Pacific. All right, let's take a look at, so enough of the MJO thing. Let's go take a look longer term at La Nina and what's going on. This is the West Pacific here. This is the, this is the East Pacific here. This is the West Pacific here. We're looking at subsurface ocean temperatures on the equator. We get the data from, these are the anchor lines on the TAA buoys. Like there's a buoy here. That is the anchor line. They put sensors on the anchor line. It goes down, well, 300 meters. That's about 1,000 feet, maybe even further till it hits the ocean bottom. And then they can take that data, load it up, use a model, and build a profile of sea surface or subsurface temperatures. Okay, and what you see is warmer temperatures. This is centigrade. In the far West Pacific, 29 degree isotherm. That's about where it's been, 165 east. 28 degree isotherm, 170, 175 west. That's about where it's been. 24 degree isotherm, it's been hanging around 135. So pretty much steady state. But what this suggests is trades are blowing stronger than normal, upwelling in the East Pacific here, drawing cold water up from depth. The warm water all gets pushed off to the west. You get colder water here. That's the hallmark of La Nina. Now, looking at anomalies, though, differences from normal for this time of year, and see the effect is far more pronounced. Here's your warm water. It isn't even that warm, 1 degree above normal. Balled up. Where's the date line? It is right there. So basically, hanging on the date line, here, let me pull this up just a little bit more. There we go. Okay, and what is real noticeable, minus 4 degrees centigrade, cold water pool, almost filling the entire East Pacific. That's a classic La Nina kind of symptom, and it should only get more entrenched over the next 2 months. We look at yet one more model using the same data. It's telling the exact same picture. 1, 2, 3, 4, 5. We'll say 6. 1, 2, 3, 4, 5, 6. Yeah, 4 degree below normal. Pool of cold water, larger than what the other model says, filling the entire East Pacific, well, the entire Pacific for that matter. The date line's right here, and nary a hint of any warm water. You go, oh, this almost looks like a Kelvin wave here, but it gets zero progress. It's locked at like 170 west. It will make no headway here. Trades, nuking, taking, just causing massive upwelling. No active phase of the MJO, no westerly anomalies to take warm water, push it off to the west. So this is the recharge mode. You call it La Nina, but really it's sort of the reaction to what has been a long-running kind of weak El Nino. We had the big El Nino in 2014, 15, 16, and then there was a moderate La Nina between that. Then for the past year or two, we've been again in this kind of weak El Nino pattern, and now there's just no warm water left. There's no momentum in the atmosphere. La Nina is taking over, and it will do it for a year, maybe 2. We're hoping only a year, and then we'll return to a more normal pattern. Ocean heights, okay, not temperature. Is the ocean surface higher or lower than normal? If it's lower than normal, that means that underneath it there's cold water. Cold water contracts, and that's what causes kind of a divot on the ocean surface. When you have warm water at depth, it expands, and that creates a bump on the ocean surface. So JASON 3 satellite data, strip out the waves, strip out the wind waves, strip out the tides, minus 10 to minus 15 centimeter anomalies. This is South America here. You actually see, you get the sense there's this giant triangle that goes from Chile out to the intersection of the date line and the equator, then the whole way up into Mexico. Classic La Nina signal. And why is that? That's because there's high pressure south here rotating counterclockwise, driving trade strong up the South American coast and then strong along the equator. Same deal up here, high pressure, stronger than normal, driving trades down the Mexican coast and then turning to the southwest and then to the west doing the same thing. And the intersection of these two high pressures is just nuking trades, upwelling, and colder than normal water. All right, what's going on at the ocean surface temperature? Really no change from what we've been seeing for weeks now. Here's South America. The equator's roughly right here. Sort of like a stereographic image here, but you get the idea. The blues, colder than normal. It's not only blue, it's purple, it's almost red. Strong upwelling. Major cool pool off of all of South America. You can see literally the outline of high pressure here and literally the outline of high pressure here, just causing nuking, trades, upwelling. Yeah, lots of warm water here and here, but it's what's on the equator that matters in terms of the global ocean circulation, specifically in the Pacific and really in the West Pacific. That says everything. But if trades are this strong the whole way across the equator to the date line, you know that there's nothing good going on in the Kelvin wave generation area. Sea surface temperature trend. Blues colder than normal, reds normal than normal. It's on everything that matters is on the equator. There's Ecuador, the equator's right there. Blue, 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 little pockets of red, balance definitely blue, strong blue pockets, strong easterly anomalies, and this has just been the pattern for weeks now. Yes, there are these red pockets, but the balance is definitely towards cooling, the blues, not towards warming, and the expectation is that's going to continue. And then, of course, the backed off view, clear La Nina signal. Now, if it was even clearer, you'd see cooling building up into here. It's not doing it yet, but you see clearly cooling the whole way down to southern Chile. We expect little hints. The expectation that will probably build as we get deeper into fall, but a clear La Nina signal in control today. Sea surface temperatures in the Nina 1.2 region. This is the Galapagos, Peru, that area far East Pacific on the equator. Dead stable today, minus 1.666 degrees, exactly where they've been since, we'll say, the 4th of July. No change. It really can't get much colder. Trades have just been nonstop there. There's no evidence of Kelvin waves, no evidence of the active phase of the MJO doing anything to try to warm up. A cool water regime in control. Now we go to the Nino 3.4 region, the official El Nino monitoring region. That's further out to the west, out, from south of California out to almost the dateline on the equator. Temperatures were normal into about mid-July, and then they've been on a steady downward drop. Today's value, minus 0.875, so more than 3/4 of a degree below normal. And you go, well, that's not much. It's only 3/4 of a degree. Well, it's 3/4 of a degree centigrade, which is really like, I don't know, we'll say 1.5 degrees Fahrenheit. But even that, you go, well, 1.5 degrees isn't much. But the reality is, all it takes is a half a degree for like 5 consecutive months to get you, minus half a degree will get you La Nina, plus half a degree will get you El Nino. It's the atmosphere and ocean interface is extremely sensitive, and minute changes in temperature make a big difference that affect the entire planet simultaneously. This is pretty deep, minus 0.875. We think we're going even deeper than this. All right, what's going on in the atmosphere? So we talked about, the MJO thing, but then when we started talking about El Nino, La Nina, first we looked subsurface down into the ocean. What's the balance of heat? Is it in the west or the east? And then we looked at the surface, and everywhere we're seeing is just cold, 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 right? So then cold water temperatures eliminate evaporation or suppress evaporation. Suppressed evaporation supports building high pressure. So what you get is this deal where the ocean starts affecting the atmosphere above it. the more the atmosphere gets changed by it, it starts driving the ocean, and the two of them start working together, and that's where we're at right now. The ocean is cold, it's supporting high pressure, the atmosphere above is building a high pressure regime. The two of them start feeding off of each other. They push all warm water almost out of the Pacific way off to the west, and it goes until it burns itself out, and then it instantly just goes boom, and it collapses, falls apart. And then all the warm water in the West Pacific and all the higher than normal ocean heights start sloshing back to the east, and then you start getting El Nino. We're nowhere near that right now, though. We're still in the buildup of La Nina. All right, so Southern Oscillation Index, difference of pressure between Darwin, Australia, and Tahiti. When you have high pressure over the Pacific, i.e. Tahiti, the index goes positive. The daily index today, positive 11.41. You can see it's been in the positive 10 range or more, positive 20 for a month now. Nary a negative, well, is there one negative reading in the past month? So that's a pretty good indicator. 30-day average takes the noise out of this. What's it tell you? Plus 10.96 today. What's the trend been? Well, we were at 6 or so, and now we're up to almost 11, and it sure seems we're going up from there. The 90-day average, lagging indicator, like 3 months late, but it takes really all the noise out today. 7.39, that's positive, and we were at almost dead neutral a month ago. When we get to about we'll say the 12 or 13 range, then you definitely know that you're in La Nina. All right, let's go take a look at this 30-day average graphed out. So here we go, 30-day moving SOI, back January 2019. So last year, remember I was saying we were sort of in like a El Nino mode. We were in the negative 10 range here, big spikes at the active phase of the MJO. And then somewhere around the beginning of this year, maybe December of last year, the index started creeping up a little bit at a time. Yeah, you get still 2 active phases of the MJO. July, remember the swell July 4th in California, solid size. Probably contributed by active phase of the MJO then, but now it's been a nonstop tear of rising SOI values. Nary an active phase of the MJO to be seen. Definitely moving towards La Nina. And the official sea surface temperature forecast for the Nino 3.4 region, that's the official El Nino monitoring region on the equator from south of California out to the dateline. The solid line is what has been confirmed data. So back earlier this year, borderline El Nino temperature-wise. Then we sort of midsummer sunk to neutral, and then the model said July 1st we were going to fall into a hole. Confirmed, we're falling into that hole, and this model says, what are we right now? We're at 0.96. That is as of like right there, and the model's tracking pretty well to that. It says, you think it's cold now? You ain't seen anything yet. We're going down to almost minus 1.95 degrees in early December. So that is very clearly a lot, and I'm understating that on purpose, a La Nina signal for sure. Theoretically, bouncing back to almost neutral as we get into the early part of summer, but we'll see. Is this the bottom and we're going to bounce back and then we're good? Or is there going to be another season of cool after this? We're hoping it's only one year's worth, but we'll see. Sea surface temperature coverage data for October, November, December. I mean, it's hard to see here, but there's South America. There's the extent of the cool anomalies, the La Nina signal, getting even more pronounced. We'll pick, here's December. We can blow that up. Get a good view in there. You see it. Clear La Nina signal. You can see if you have easterly trades, massive upwelling, that's how you get this. And then all the warm water gets pushed to the West Pacific and sort of shunted north and south. It couldn't be more classical on La Nina signal if there was the big cool water anvil or triangle. And, that's kind of what it appears we're heading towards, even into March still it's hanging on. That will change the entire global weather circulation. And even if this temperature, cold water finger disappears, even after that, it'll take 3 to 4 plus months for the jet stream to start reorganizing. And this is what, the March data, March 2021. My guess is it'll be July till this starts dissipating. And so it won't be till even maybe later in the fall of 2021 to when we start returning to normal, assuming this is only a 1-year La Nina event, which seems likely given how strong this signature is. All right, so much about the doom and gloom. The good news is right now, there's Gulf storm happening right now, producing swell. Swell is radiating towards the California coast. And 2 other systems behind that with energy radiating towards Hawaii and the California coast, U.S. West Coast. And then maybe more after that. Jet stream looking pretty good. On top of that, southern hemiswell, 1 in the water, maybe another coming. So there is a plethora of surf opportunities headed our way, at least for the next, we'll say 2 weeks, 2.5 weeks, something like that. After that, unknown. Sort of looks like the inactive phase, the MJO, is going to set up at some point, and then we're going to fall into a hole. So make the most of this while you can. We've said that before during La Nina years. When there's surf, you do not tarry. You go, you surf, make the most of it, be happy for what you get, keep a smile on your face, and keep the stoke up. All right, beyond that, looks like La Nina. We all know that. We've been saying it for months now. We're not going to beat a dead horse. And all the models are just confirming that data as well. So that's the way it is. We all know that. All right, if you enjoyed the video, give us a thumbs up. We'd really appreciate it. Comments, always welcome. Especially comments, deep probing questions about weather. We'll do our very best to answer them. And of course, if you haven't subscribed, please subscribe. It sort of does good for our channel, helps feed our channel, and you get email notifications when we post the videos. If you don't want to do that, that's okay too, though. You can go to stormsurf.com. The links will be at the top of the page, the videos after we post it, and you can watch it there. All right, and of course, all the data that you see in the video here is available on stormsurf.com. Thanks for watching. We'll do this again next week. Same time, same channel. Thanks for being with us.